Welcome back to PSpice. In this session, again, we'll continue with the industrial communication. In part three, we'll focus on the communication methods. Okay. So just remember this diagram, friends. This is a master and we have a slaves. This is what I am going to explain. Of course, this is one of the item in the communication methods. Okay. So yeah, of course, in the first part, we focused on protocol and network topologies and OSI model. The second part, we focused on the hardware and cables used for digital communications. And now in this session, we are going to talk about the communication methods and also the interface standards and devices. Okay. We are not going to limit to this, and we are also going to cover the proprietary controls and open protocols. Okay. Yes. So let's get on with the details. Yes. When we talk about the communication method, you know, we have three communication methods used very common in network, right? Master slave and token ring and Ethernet, right? So master slave communication is quite simple. That's used in the industrial controllers. So in this technique, what we are doing is a master device issues commands to one or more slave devices and the slave responds. That's it, as simple as that. Okay. So for example, a PLC, which is connected to a three external remote tracks, maybe the master, right? Every 40 seconds, the PLC processor first checks for any altered inputs in the local rack, right? Local rack in the sense where the processor is located. Then it sends a query to the first external track to see whether any inputs are changed, right? Or any hardware failures are occurred. Okay. So any changes are reported back to the processor, and the process is repeated for the second external rack after querying of the first rack is done. And the third rack after the second rack has been checked. Okay. So then the processor runs its program and changes any outputs if necessary. Then it sends or writes new data to the output register of modules in the local track, right? And three external track. So this is how it works actually, master-slave communication. Okay, then we'll talk about the token ring. Token ring relies on token passing for data communication. As the name suggests, token ring communication is used in ring network. Okay, a special message called the token is passed from one machine to another around the ring, and each machine can transmit only while it is holding the token. You got it? So token ring network never became prevalent in business in industry. However, token passing doesn't require a ring network for user. It can be and is used on the network of other topologies. So to sum up, so it's rely on the token passing for the data communication and it is used in the, what is that? Ring network. Okay. So here the special message called the token is passed from one machine to another around the ring and each machine can transmit only while it is holding that token. Okay. Right. So that is the point. Then Ethernet. Okay. Ethernet is essentially a method of communication between computers and other devices on the network. Right. This you all know. Right. So Ethernet makes use of carrier sense multiple access with collision detection. Meaning like, sum up carrier CSMA CD. Yeah, that is what it used this methodology. Okay, use carrier sense multiple access with collision detection. Okay, so on an Ethernet network, any node can communicate with any other node. It works like this. Like, consider, for example, first, before a computer or a controller sends data to another device, hmm, before a computer or controller sends data to another device, it listens to see whether the network is busy. If the network is active, it will wait and try to send data later. If it senses the network is available, it will transmit the data. However, due to the network time delay, a node may start sending data before it senses data released by another network node. So in that case, the data collision occurs and neither node will be able to successfully transmit data. So afterwards, each device will wait for the random amount of time before attempting data transfer again. So Ethernet works better than any other method of a large network. So that is why the internet uses Ethernet. And the use of Ethernet method has become common among industrial controllers. Furthermore, the communication speeds on Ethernet networks are very fast, typically 100 megabits per second, Mbps or higher. Okay, so that is what the Ethernet communication. Okay, friends, you got it? Okay, so that's all about the communication methods: master slave, token ring, and Ethernet. Okay, so before going into the interface standards and devices, want to touch upon bit on some aspects. You know, friends, peer-to-peer communication. Yes. So when any network can transmit data to any other node in the network is called peer-to-peer network. Okay. When any network can transmit data to any other node in the network is called a peer-to-peer network. So peer-to-peer capability is only possible if the application layer protocol supports it. If you remember the OSI, yes, that application layer, seventh layer, right, supports it. So peer-to-peer network can be implemented on network with many different topologies, and a master-slave network is not a peer-to-peer network. Just remember that. Okay. So this is just about a piece of info. Okay. Then also, yeah, I think that's it. We'll go into the interface standards and devices. Okay. Interface standards and devices or, yeah, there are many types actually. Oh, one is the USB, right, friends? So USB, what is the USB? It's a universal serial bus. In fact, I covered this a little, I mean, in the part 2 also. So basically, this is a interface standard. It is used for point-to-point connection for a wide variety of purposes, such as, between a mouse or a printer or a computer, right? So USB 3 allows communication at up to 5 gigabit bytes per second, GBps, and USB 4 supports 40 GBps, and USB has replaced the much older and slower RS-232 interface, which was used in the legacy computer. So this is one of the device, USB, Universal Serial Bus. Okay. Then we have RS-485. RS-485 is an interface standard for data communication that allows data transmission speed up to 1 megabit per second, 1 Mbps on a 100-meter cable. Okay. So data communication speed varies inversely with the total length of a RS-485 cable. Okay, friends, you got it? Yeah. So this is about the 485. See here, the shorter the total length, faster the speed, and vice versa. Meaning the lengthier is the length, mean longer the length and slower the speed. And at RS-485 terminal and on conductor, a small negative voltage represents a off bit and a small positive voltage represents a on bit. That is how the mechanism works actually. Okay. So most often the RS-485 network consists of point-to-point connection to nodes from a bus cable, right? So twisted pair wiring is used for the bus cable. Okay. So RS-485 offers high immunity to electrical noise when implemented properly. Okay. And of course, we need to have this terminator at the end of the network to minimize the such an issue actually, like that. Okay. So in RS-485 network, one master device communicate with the slave. So it is basically a relatively inexpensive network to supply and installed onto controllers. So this makes it a very attractive option for relatively simple network and applications. Okay, so you can see that RS-485 is widely used. Okay, so that's about RS-485. Okay, right. Then we go into a little bit Or maybe you can ask where and all it's used. Yeah, it's used in, power monitoring system and also the HVAC system, where the system parameters change slowly and fast communication is not essential. There we can use it. And then we have 8 PHC, that is 8.8 connector ports. So 8 PHC, 8.8 connector ports, cable connectors have 8 conductors, and yeah, and 8 P8C connectors are attached to a twisted pair copper Ethernet cable. For example, category 6 cable, right? Yes. So 8P8C ports are built into the network interface cards in computer. Okay. Ethernet switches and also media converters and other devices. So various sizes and shapes of connectors, including RJ11, RJ45 phone cable, are part of the 8P8C group. So this is about the APHC. Okay. Then we have a converter, right? So converters, as you know, converters can be bought to allow different types of serial devices to interface. One example is this RS485 to USB converter. Right. So this is about the converter. Okay. I think that's all. Yes, that's all for this session, friends. So next session, I'm going to bring you a very, very important topic, which is about proprietary and open protocol, wherein will cover focus on hard protocol and TCP/IP. In fact, we covered extensively, but we'll touch upon briefly. And Modbus variant, which is about, RTU, Modbus RTU, Modbus TCP/IP, and also we'll talk about the Rockwell Allen Bradley protocol, such as Common Industrial Protocol. We call it as a CIP, and Control Net, Ethernet over IP. All these will focus. Thank you for watching and see you in the next video. Take care. Bye bye.